Our goal here is systemic synthesis. We want to move from isolated findings, variable A increased, or theme B emerged, to a holistic systemic understanding. We rely on the core axiom of systems theory. The whole is different from the sum of its parts. You can't understand a car by looking at a pile of car parts. You have to see them connected and moving. Similarly, we focus on the relationships between data points, not just the points themselves. The magic is in the connection. How does the qualitative theme of fear relate to the quantitative drop in attendance? The relationship asterisk is asterisk the finding. When looking at your data, I want you to hunt for complexity markers. The first and most important is the feedback loop. Traditional science looks for linear cause and effect. A causes B. Systems thinking looks for circles. A causes B, which then loops back to influence A. There are two types. Reinforcing loops amplify change. Think of a snowball rolling down a hill, or a vicious cycle of poverty, where lack of money leads to poor health, which leads to lost work, which leads to less money. Balancing loops resist change. They seek homeostasis. Think of a thermostat or a bureaucracy that absorbs reform efforts and returns to the status quo. Identifying these loops explains asterisk why asterisk a problem persists despite interventions. The next marker is emergence. Emergence refers to properties that arise from the interaction of parts, but belong to the system as a whole. You cannot find traffic by looking inside a car engine. Traffic emerges from the interaction of thousands of cars. Similarly, culture, or trust or panic, are emergent properties. In your data, look for behaviors that cannot be explained by looking at individuals alone. If everyone is acting rationally, but the outcome is irrational, you are looking at emergence. You have to interpret the system, not the individuals. We also look for non-linearity. In a linear world, a small push gives a small result, and a big push gives a big result. In a complex system, that's not true. Small changes can have disproportionately large effects. We call these tipping points, or butterfly effects. Conversely, huge efforts can yield zero results if the system absorbs them. When interpreting your data, be cautious of simple linear explanations. If you see a sudden, massive shift in your data, don't assume a massive cause. Look for the small trigger that tipped the system. Look for the straw that broke the camel's back. To manage all this complexity, we use a technique called mapping results. We physically map the system. We use tools like causal loop diagrams to draw the connections between our findings. We draw the circles. We map the feedback loops. This visualization is crucial because our brains aren't great at holding complex dynamic systems in memory. Drawing it out prevents reductionist conclusions by making the complexity visible. It forces you to acknowledge that A is connected to B, which is connected to Z. It keeps you honest. I feel like I'm beating a dead horse, but I have to mention avoiding reductionism one last time. Systems analysis is hard. It is messy and confusing. The temptation to simplify, to just find one root cause and ignore the rest, is overwhelming. You must have the discipline to hold the complexity, even when it is uncomfortable. Your final outputs should be descriptions that acknowledge uncertainty and interconnectedness. Don't promise simple answers to complex problems. Offer robust maps of the territory. The huge payoff of this approach is finding leverage points. These are places in the system where a small shift in one thing can produce big changes in everything. This concept, popularized by Donella Meadows, is the holy grail of transdisciplinary research. Instead of trying to push the boulder up the hill, you find the pebble that is holding the boulder back. Using your data to identify these leverage points is where research translates into high-impact strategy. It allows us to work smarter, not harder. Finally, this moves us from analysis to action. A systems view radically changes our recommendations. Instead of saying, treat the symptom, like giving food to the hungry, we might say, alter the feedback loop, changing the laws that prevent access to land. We move from band-aids to surgery. Solutions based on this level of analysis are usually far more sustainable because they work asterisk, with asterisk the system's dynamics rather than fighting against them. To synthesize Module 4, we have traveled a long arc. We started by putting quantitative data in context. We moved to qualitative meaning making. We integrated those streams. We examined our own reflection in the mirror through reflexivity. And finally, we mapped the whole thing as a complex system. The outcome is a rigorous, multifaceted interpretation of reality that honors the complexity of the world. We are now fully prepared for Module 5, where we will discuss ethics and impact, what we actually do with this knowledge. To summarize Lesson 4.5, move from isolation to synthesis. Identify complexity markers like feedback loops and emergence, and map your results physically to ensure you are not reducing a complex world into a simple but wrong conclusion. Thank you for your hard work in Module 4. I'll see you in Module 5.